So here's a complex one. This is phosphoric acid, so H3PO4 plus barium hydroxide, which is BaOH2, goes to form barium phosphate, Ba3PO4 plus H2O, okay? So put the equation in general form. So I just put A, B, C, and D. Every single time we just do this, okay? Unless, of course, you've got a faster way. So set the coefficient of the most complex chemical to 1. This is a sort of one of those things that is not immediately clear. For me, I think this one's probably the most complex. A lot of people would say this one's the most complex. It really doesn't matter. Like I said, you can pick any one. It's up to you. So seeing as it's arbitrary, let's just say A equals 1. A equals 1. Just remember, you can pick any of them, so don't be worried. Just pick any of them, but I just picked A. So as maybe a homework exercise for you to do on your own, try doing it by setting each of these ones, B, C, D, to be 1, and then work through the rest of the steps that way, and you'll get the same sort of answer. So if I set A equals 1, this is our equation. You can see that A has become 1. Now check which elements appear in only one product and one reactant. So if we look at it, P, phosphorus, appears once here, once here. Barium appears once here, but hydrogen appears here and here, and here. So hydrogen's not a good choice because it appears twice on the left-hand side. And oxygen's not a good choice because it appears here and here. It appears in 2 on both sides. So we can see P and Ba both appear in 1. So we balance these first. The ones that only appear on once on either side, we balance first. So we write balance equations for these chemicals. So we balance it up. We use the conservation of mass. We say the left-hand side has to equal the right-hand side. So for phosphorus, you got 1 phosphorus here. You got 2 here. Well, 2 times C. So 1 equals 2 times C, because there are 2 phosphorus atoms in this whole thing here, okay? Now for barium, you've got B on the left-hand side. You've got B numbers of barium. And you've got 3 times C on the right-hand side. Okay, so B has to equal 3C. Now balance for oxygen. You got 4 on this side. You can see there's 4. Plus 2 times B, because you've got 2 here and B at the front. And on the right-hand side, you've got 8 here times by C, so 8C. And you've got 1 here times D, so you've just got D. Okay, so this is our balance equation for O. Finally, you got your balance equation for H. So you got 3 here, and you've got 2 times B, so 2B, and that has to equal 2D. Okay. Now we just solve the equations. Now since 2C equals 1, C equals a half. Now if we substitute that back into the Ba equation, B equals 3 on 2. Substitute B and C into the O equation, which is this. So we get 4 plus 2 times 3 on 2 is 3, equals 4 plus D, because C is a half, so D equals 3. And then we substitute all the numbers back into this equation, and we get H3PO4 equals 3 on 2 BaOH2, and that goes to a half Ba3 plus 3 H2O. Now you can go through, actually check which ones are right and which ones are wrong, if it's correct, because you should have equal numbers on both sides. Let's just talk about hydrogen. You've got 6 here. Now here you've got 3. You got 2 times 3 on 2, which is 3. So 2 times 3 on 2 is 3. So you've got 3 plus 3, which is 6. So you've got balance for hydrogen. So if you go through and try to balance each of those different elements, you'll see that they all balance up. And if they don't, then you've done something wrong, okay? So you've made a mistake. So that's how you check if you've made a mistake or not. Okay? Now, what about this one? Balance Cu plus HNO3. So this is copper plus nitric acid, which gives you copper nitrate plus nitrous oxide plus water. First, we write it in general form, just putting A, B, C, and D, also E, sorry. And then we set the coefficient of the elemental metal to be 1, okay? So we set A to be 1, and so we write balancing equations. To balance for the copper, we have A has to equal C, because it has to be the same number of coppers on both sides. So A equals C. For hydrogen, B has to equal 2 times E, right? There has to be the same number of hydrogens on both sides. So 2E hydrogens on the right-hand side has to be the same as B hydrogens on the left-hand side. So we get B equals 2E. Now for nitrogen, this one's a bit harder because you've got B on this side, B times 1. That's how many nitrogen atoms we have on the left. But on the right-hand side, we've got 2 times C, so 2 times C, plus D on the right-hand side. So we have 2 times C nitrogens plus D nitrogens on the right-hand side, and B nitrogens on the left-hand side. And finally, oxygen. This one's probably the hardest because there's so many oxygens. But you've got 3 times B oxygens on the left-hand side, which is here. 2 times 3 times C, which is 6C. 2 times 3 is 6, plus times C is 6C. D times 2 oxygens, so 2D, plus E oxygens. Okay, so this is the balance for oxygen. So now we list what we know. We know that A equals 1. We've set that. So that means C also equals 1. Okay, so we know those two instantly. From the nitrogen balance, we got this equation. So if we substitute C into this, we get B equals 2 plus D. Right? From the hydrogen balance, we got this. And so E equals a half B. You can sort of manipulate this as we go along, but so how you solve these equations is totally up to you. This is how I did it. If we substitute 2E for, or B for 2E in this equation, we get 2 plus D equals 2E. Okay, so we're just substituting B. Okay, so now we've got equations 1, 2, and 3. Now from oxygen balance, we've got this. Now we substitute 1, 2, and 3 in, and we get 3 times 2 plus D equals 6 plus 2D plus a half times 2 plus D. Okay, now if I take this whole term and subtract it from this side and subtract it from this side, we get 3 minus half is 2.5, and the fractional form of that is 5/2. Just imagine this was like x or something. And this would be the same, this would also be x. So it'd be 3x minus a half x, which is 2.5x. And that's that. Okay. Now I'm expanding the brackets. So I get 5/2 times 2 is 5, plus 5/2d, because I'm multiplying the 5/2 in. Now if I rearrange this and simplify, we get a half d equals 1. Okay, so I'll leave that for you to do. And so d must equal 2. Now if I sub back into each of the previous equations, so b equals 2 plus d, so if I substitute d, I get 4. 2 plus 2 is 4. Now that I know this, if I substitute this one back in here, e equals a half b, and b is 4, e must be 2. And so I put it all into my final equation, and there it is. A equals 1, b equals 4, c equals 1, d equals 2, and e equals 2. So that concludes today's lesson on balancing chemical equations. We've looked at what are the steps of balancing equations, and we looked at a foolproof way of doing it. As you get better and better at this, you don't have to follow this as rigidly. You'll be able to use your own techniques and use your own intuition to solve these problems. So I look forward to seeing you at our next lesson.